Amazing students, welcome to another video of iCampSA. This is for grade 10 mathematics, and today we're going to be doing parabolic functions. It's part of a series of functions. After the introduction we've already done on linear functions, we are now moving to parabolic functions. But before we get there, I just want to quickly touch on something that I remember that we didn't get to cover on our last sessions, when we were dealing with the linear functions, and that is the horizontal and vertical lines, and the equations of the horizontal and equal lines. So when you just have a horizontal line, so that is a line with basically no gradient, it's just a flat line. The equation of a horizontal line will be y is equal to n. Y is equal to n, and n is the variable for any real number, and then you will see the horizontal line on the set of x's to be like this, as I'm highlighting it there. That will be just your horizontal line. And in this example here that we have, the equation of the horizontal line is just y is equal to 2. Y is equal to 2. And we also have vertical lines, and the equations for the vertical line is what now is x is equal to n, and n is any real number. N is any real number, so, and then the way you're gonna see it's on the, what you call this thing, on the what is this thing, on the sets of x's, it's just gonna be a line like this. It's just gonna be a line like that one that I've just highlighted, and then it's x is equal to 3. X is equal to 3. So yeah, those are the equations of the horizontal and vertical lines. And the reason why I'm touching on them is because as we move forward and we get to deal with things like asymptotes, you'll start to see the need of understanding the way to present the horizontal and vertical lines. But without wasting any more time, let's get into today's lesson, which is parabolic functions. Parabolic functions, okay. They are sometimes called quadratic functions, or plainly just parabolas. Plainly just parabolas, as you can see. So with parabolas, we have this mother graph. This is an equation of the mother graph. Equation of the, let me just say, parent function, of the parent function. So this is the most basic parabola, or a quadratic function that you can get. This is the most basic parabola or quadratic function that you can get, and the shape of this simple quadratic function will be something like this. Will be something of this nature. It's just going to be a curve. But maybe to drive this point home, let's actually sketch this parabola or this mother function the normal way that we will sketch our functions, and that by using the tables. And then let's take what numbers, let's sketch the function, and then for the x values, we're sketching that function of y is equal to x squared, the mother graph or the parent function. For the x values, let's take minus 2, minus 1, 0, 1, 2, and then let's find the corresponding y values. So negative 2 squared is going to be what? Is going to be 4. Negative 1 squared. And remember that to find the y values, we substitute the values we substitute the x values in the equation. So wherever we see x, we just put the x values that we have here. So negative 1 squared will be just 1, and 0 squared will be 0. 1 squared will be 1, 2 squared will be 4. And then once we have the corresponding coordinates, let's go ahead and now sketch the coordinates. We can start at -2. -2 corresponds with what? It corresponds with 4. So we're gonna have a point there, corresponds with 4. That's -2 and 4. It's -2 and 4. And then next, another point is -1 and 1. So -1 and 1 will be here, just about halfway there, and then the next point is 0 and 0. Next coordinates 0 and 0. The next one is 1 and 1, just halfway there, it's 1 and 1. And then next one is 2 and 4, yes. And then once you have this points on your sets of x's, you simply join them with the curve, and remember, this is not a straight line function now, it is a curved function. Like this, and you put our arrows there to represent that this function is continuous. Okay, and then and that basically is the parent function of the parabola, or the quadratic function. And then next, what do we have here? We have a general equation, so a general equation is what we use it's how you're gonna see your equation once transformations has been made into the parent function. So there are multiple transformations that we can make into that equation. We can stretch it, we can move it up and down, just like we were doing for the linear functions. So multiple transformations can be made in that parent function or parent equation in order to obtain now the general equation of the parabola, of which is the one that we have there, and it's y is equal to ax squared plus q. And then now let's go ahead and see what does that coefficient of x squared represent. So a is used to determine closeness of the arms to the y-axis, the closeness of the arms to the y-axis. So when you are referring to the arms, those are the arms of the curve, so it's the closeness of these arms to the y-axis, so that is what we are referring to. So if we were to change the value of a, maybe increases or decreases the closeness of the arms to the y-axis, maybe the arms will move further away, just like this, or they will move actually closer. Just like this, So that is controlled by which variable? By the a variable, the coefficient of x squared. So let's see what is happening. Next, the larger the value of a, the larger the a, the closer the arms to the y-axis. So when we increase the value of a, of which is the coefficient of x squared there on our general equation, what happens to the arms? The arms get closer to the y-axis. So as you can see from our graph there, the graph that is closest to the y-axis is the red one, which means the red one has the largest a. I'll just say it has the largest value of a, and then progressively we'll have the purple function being less than the a of the purple function will be less than the a of the red function. And as you go out to the green function, the value of a keeps on decreasing, because the larger the a, the closer the closer the arms to the y-axis, But we're gonna do an example to actually demonstrate what we are referring to here. just for now, keep in mind that the value of a determines the closeness of the arm to the y-axis. And also the sign of a can be altered, so we can have negative a or a positive a, or we can just represent it as a being less than 0 and a being greater than 0, so that also changes, or alters our function. So what happened? The sign of a determines the direction of the opening of the graph, so if you remember, with a in the linear functions, what happened? With a in the linear functions, it reflected the function about the x-axis. So this is basically the same thing once again. So the sign of a, if a is negative, the sign will be reflected, it reflects the graph about the x-axis, so if we were to have a negative a for that purple function, what you will see happening is that the function will now be like this, will be represented, or will be reflected, about the x-axis, just like I've represented here, so that is what the a does, or changing the sign of a does to the function. So sign of a reflects the graph about the x-axis. As you can see here in these two statements that I've made, a greater than 0, so a positive a will be concave up, meaning our graph will be facing up, just like these three functions that I've drawn here. And if a is less than 0, a negative, the graph will be concave down. A less than 0, the graph will be facing down, just like the one that I've drawn here. That will be a negative a. Okay, and then next, another transformation that can be done will be represented by that variable q. Let me quickly highlight the variable q. So what does adding or subtracting the variable q does to the function? If you remember, we had a similar situation with the linear function, whereby the q causes a what? The q causes a vertical shift. So as you can see here, the q determines the shift of the graph up or down. It determines the shift of the graph up and down, up or down, of which is what? Is the vertical shift. Is the vertical shift. So q determines the shift of the graph up or down, and it also determines the y-intercepts of the graph, so where our graph cuts the y-axis. Let's say that graph of negative a, that purple graph, was shifted maybe a few units downwards. What you're gonna have now is something of this nature, and then you're gonna have your y-intercepts there, where our graph cuts the y-axis. So that also is determined by what? It's determined by the value of q. So that is your general equation. Now let's go and do some examples in order so that you can see visually see what happens when we alter these things, when we increase or decrease the value of a or the value of q, or when we change the sign of a or when we change the sign of q. So for example number 1, on the same set of axes, sketch the following group of parabolas. So we have 4 parabolas here, which is the first one is 1 over 4 x squared. It's 1 over 4 x squared. So here we only have the value of a and not q. I want to highlight something for you guys. So here, as you can see, that a is what? A is 1 over 4. And then for function number b, we have what? Y is equal to x squared, which is actually the parent function. So for that parent function, what do we have here? what we have, so when you just have y is equal to x squared, so when the coefficient is not written, we must always know that the coefficient is 1. When there is nothing written next to our variable x, you must always know that the coefficient is 1. Let me put that in brackets. So for this one, it's just gonna be 1. That's the value of a. And 1, and 1, the value, is 1, the coefficient of the second function is actually greater than 1 over 4. 1 is greater than 1 over 4. And then we go into sketch of function number 4, of which is y is equal to 2x squared. The value of a is what? Is 2. And then for the last function, the value of a is 4. As you can see that the value of a increases from a, b, c, and d, so I just wanted to clarify that. And then now let's go ahead and sketch these functions Okay, so let's go ahead and sketch these functions. Okay, let's sketch these functions. Maybe let's start with the table, the x values. Let me see, what will I use is with the x values that start from -2, -2, -1, -1. Let me use blank. So the x values is gonna be -2, -1, 0, 1, and 2. Before we sketch, I think it will make things easier for us. So for function number a, the corresponding y values, when we say 1 over 4 times, okay, so the corresponding values for the first function, which is y is equal to 1 over 4 x squared, -2 will go with 1, and then -1, I think it will go with 1 over 4, 1 over 4, which is a quarter, and then we're gonna have 0 and 0, 0 and 0, and 1 is 1 over 4, 2 is 1. Okay, and then next, for the following function, which is p, for p, the corresponding y values for function of p, maybe let me do it like this, then this is for function of p. Okay, p is equal to y is equal to x squared, so it's just gonna be 4. That's the parent function. If you remember, we're gonna have 4, 1, 0, 1, 1, 0, 1, 4. And then let's go to number c, which is 2 multiplied by -2 squared, which is gonna be 8. The corresponding y values of that c function is 8, and then for -1 is 2, and then for 0, and for 0, what is it? What do we have for 0? 0 and 0. Okay, this has not been shifted. Okay, and then 1 is 2, 2 is 8. Okay, and then for function number d, okay, for function number d, we're gonna have for -2, we're gonna have 16. Sorry, it's blue. Corresponding y values for -2 is 16, and then for 1 it's gonna be 4, 0 for 16. Okay, now we have the values we can sketch the functions. Okay, let me see, maybe I could have, so that we can have a little bit more space for the function. Let me put this here. Hopefully that won't cause any confusion. Okay, yeah, and then let's draw our Cartesian plane. Cartesian plane. Then we're gonna have, say, 2, 4, 2, 4. Well, how we will get to 16? Let's maybe use 4, 8, 12, 16 there. This is 4, 8, 12, 16. And then here let's use 2, 2, 4, or 1, 2. Yeah, just use 1, 2. Yeah, I'll use a different scale because the y values, they increase pretty quickly here. Okay, and then we're gonna have 1, 2, 3, 4, -1, -2, -3, -4, and then here we said we're gonna use 4, the intervals of 4, 4, 8, 12, 16, -4, -8, -12, -16. Okay, now let's plot our function. We'll start with the first one, maybe just to show what goes together. This is the first function. So for -2, what do we have? -2 goes with 1, so 1 will be somewhere here. Oh, sorry, now I'm using a different thing. -2 and 1, and then we're gonna have -1 and a quarter. A quarter would be very close to the will be very close to the x-axis, and then we're gonna have 0 and 0. Next, 1 goes with 1/4. Okay, 1/4 would be somewhere here, and then we're gonna have 2 and 1 somewhere here. And then let's join our dots for the function. The function will be something like this, will be something of this nature. And then let's draw on the other side. And remember that the value of a here is what? Is 1/4, the coefficient of x. A is equal to 1/4 for this one. Next, let's do number b. Here are the values of the function of b. So -2 goes with 4. -2 goes with 4. So -2 goes with 4. So we're basically matching the coordinates here. This is what I'm referring to. -2 goes with 4, and then -1 goes with 1. -1 goes with 1. It should be somewhere just above this, and then 0 and 0, and then 1 and 1, and then 2 and 2 and 4. And then what do? We draw our function, or the arms of the function, or the branches, whichever one you would like to call them. I'm trying to extend this function. Okay, so that is the arm of the function. Next, let's do number c, function number c. So for function number c, remember that 8 goes with -2. So those are the coordinates. Please don't get confused. Hopefully the colors will help you to keep track of that. So -2 goes with 8. -2 goes with 8. And I want you to notice something, that as the coefficient or as the value of a increases, what happens? We are moving closer towards to the y-axis, because as we have mentioned here, that the larger the a, the closer the arms to the y-axis. So just keep track of that. And then -1 goes with 2. -1 goes with 2, so it's just gonna be the half here. Okay, and 1 and 2, 2 and 1 and 2 and 2 and 8, 2 and 8, somewhere there. Okay, and then what do you do next? You connect the points. You connect the points to make your curve. Why do I keep on drawing larger curves on the other hand? I don't know why, but it's okay. And then next, let's do number D. Let's plot graph number D. So for number D, we have what? -2 and 16. -2, and see here's -2 and 16 is there at the very top. And then next we have -1 and 4. -1 and 4, so it's gonna be here. And then we have 0 and 0, 1 and 4, and then 2 and 16. 2 and 16. You join our dots. 2 and 16. 2 and 16. 2 and 16. So as we can see here, that as we are increasing the value of a for number b, or function number b, our a is what? Is 1. And then for function number c, our a is what? Our a is 2, is equal to 2. And then for function this one here, for function number d, number last, our a is equal to 4. What happens? The arms are moving closer and closer to the y-axis, So as the value of a increases, the arms moves closer and closer to the y-axis. Hopefully this sketch was able to demonstrate that to you. You know that as we increase the value of a, our function becomes thinner and thinner, if I may say. So yes, that comes back to what was said here. The larger the a, the closer the arms to the y-axis. The larger the a, the closer the arms to the y-axis. Okay, and then next, let's go ahead and do example number 2. Okay, so what else did we introduce about the value of a is that sine of a reflects the graph about the sine of a reflects the graph about the x-axis. So the sine of a reflects the graph about x-axis. Let's go ahead and do example number 2. So on the same set of axes, sketch the following parabolas. So we have 4 sets of parabolas. You know, they both have let's just go ahead and sketch this function, because I almost say they both have the same value of a, but they don't. Okay, so you can see that function, maybe before we get started, function number a has the coefficient of x squared as what? As 1. There is no coefficient there, so it's just 1. And also function number c of y is equal to -x squared has the coefficient of x squared as -1. that is just -1. Okay, and then we have the other ones, which is y is equal to 1/2 and y is equal to -1/2, so let's see what happens when we change the sign of the coefficient of x squared. So in fact, let's just sketch function a and c first, and then we'll sketch function b and d. Okay, so let's quickly do the table. Let's select values of x. We're gonna go again with -2, -1, 0, 1 and 2, and then the values of y. Okay, so here we're gonna be doing function number a. For function number a, the values of y: -2 squared is 4, -1 squared is 1, 0, 1, 4. And then we're also gonna sketch the function of what? Of c, the function of c, of which is -2 squared is gonna be what? Okay, this is the function of c, y, -2 squared. So we have, when you are substituting in your calculator, you write it like this. We have that negative, open bracket, -2 squared, and then you punch it like this in your calculator. It will give you what? It will give you -4. And also, when you are punching for -1, where x is -1, what do? You negative, open bracket, -1 squared, because you are accounting for this negative x there that we have. Okay, I'll just keep that there for now, so that it serves as a reminder. So you're gonna have -4, -1, 0, -1, -4, -1, -4. Okay, for now let's just sketch these two functions a and c. So they have the same value of a, which is 1, but the other one is negative, the other one is positive. Okay, so let's see what happens. We've already mentioned or introduced what happens when we change the value of a, but now let's graphically represent that. So this is our Cartesian plane. 3, 4. This is our Cartesian plane. So we're gonna have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. -1, -2, -3, -4, and these are also negative. And also, don't forget to always label your axes. Okay, so let's plot the points. For the first function of a, y is equal to x squared. We have -2 and 4, so -2 and 4 will be there. That is your -2 and 4, and then we have -1 and 1. -1 and 1 will be here, and then we have 0 and 0. Next we have 1 and 1, and then we have 2 and 4, and therefore, and then next we join our points. And that is the function of y is equal to x squared. Now let's plot the one for c, which is y is equal to -x squared. So for -2 we have 4. Sorry, we have -4. We have -4 here. -4, and then for -1 we have -1. It's gonna be here. 0 and 0, 1 and -1, 1 and -1, and then 2 and -4 here. And then let's join our points. Let's join our points. Okay, so now will you look at what had just happened? Just look at what it just happened. Okay, please forgive me for the it's a bit ugly. Sorry. Yeah, it's not perfect. I'm trying to make it perfect, but you get the idea. We have these points here, and this function is the function for c, which was actually y is equal to negative x squared. So this is y is equal to negative x squared. So you see what has happened. We have changed a here was 1, and a here is what is negative 1. So they have the same value of 1, it's just that it's different sign. And we said when we change the sign of a from positive to negative, the function will be reflected about an x-axis. Imagine as if you are placing a mirror on the x-axis, on this line here, the x-axis, and you see what happened. This function that we had here is now reflected about the x-axis, so it has been moved and reflected to the bottom of the x-axis, so that is what happens when we change the sign of a. This is the a that is the coefficient of x squared is what we are referring to there. Okay, once again, let's also just do b and d, because you can see that for function b, for function b, a is what? For function b, a is equal to 1 over 2. A is equal to 1 over 2, and then for function d, a is equal to negative 1 over 2. So what has just happened here? The function or the value of a is still 1 over 2 for both functions, but the other one is negative and the other one is positive. Okay, let me move this one a bit here. Yeah, because now I do want to let's deal with function number b and d. Let's deal with function number b and d. So now we are here on these two functions. Let's start with the table, the values of x. Let's go again with negative. Okay, this is for x. I'm gonna go with x negative 2, negative 1, 0, 1, 2, and then for function number b, let's find the corresponding y values, for function number b. So we're just simply gonna substitute negative 2. So you just go in your calculator and say 1 over 2 multiplied by negative 2 to the power of 2, and that will give you 2. And then for negative 1, you get 1 over 2, it's just half, and then 0. For 0, you get 0 again. Get 0, and it's just gonna be 1 over 2 and 2. 1 over 2 and 2. Okay, and then let's do for t. The y values for t. So t is negative 1 over 2. Remember how you punch it in the calculator? You say negative 1 over 2 multiplied by negative 2 squared, and then you're gonna get a negative 2, and then here you substitute negative 1 the same way I've been telling you. we're gonna get a negative 1 over 2, and then we're gonna get 0, negative 1 over 2, we're gonna get a negative 2, and negative 2. Okay, and then from there, yeah, let's go ahead and plot these functions. Start with the function of b, where x is negative 2, b is 2, so negative 2 corresponds with 2, and then negative 1 corresponds with half, so it's gonna be here. Okay, and then let's go, 1 corresponds with half, and then 2 corresponds with 2. 2 corresponds with 2 here. Oh, and then I forgot to put 0 and 0 there. And then from there, you simply just join your points. You join the points. It's gonna be something like that. Yes, it's gonna be something like that. It's gonna be something like that. And look what is happening here. You remember that as we increase the value of a, the coefficient, which is the coefficient of x squared, our function gets closer or becomes closer and closer to the y-axis. So in other words, when we decrease the value of a, our function moves further and further away from the y-axis. That is what we are seeing happening here. The value of a for the a function was 1, and then the value of a for the b function, the blue function, is 1 over 2. 1 over 2 is less than 1, so that's why we are seeing the function now moving away from the y-axis. Okay, but we are not there. We are not there right now. We have moved past that. Let's plot the d function, which is y is equal to negative 1 over 2 x squared. So negative 2 and negative 2, so this one will meet here. And then the next point we have negative 1 and half, so it should be somewhere here, and then we have 0 and 0, we have 1 and negative half there, and then 2 and negative 2, so there. And then let's join our points. Let's join our points. Okay. My bad. Negative 2 and 2. So yeah, and then let's come here. Okay, see. The drain function was y is equal to negative x squared. Y is equal to negative x squared. The red function is y is equal to negative 1 over 2 x squared. And then the blue function is y is equal to 1 over 2 x squared. So you see what is happening here. By changing the sign of a, the function has been reflected about the x-axis. The function has been reflected about the x-axis, which is what was said here. The sign of a determines the direction of the opening of the graph, or the sign of a reflects the graph about the x-axis. And then lastly, we have q, which q determines the shift of the graph up or down. So q determines the vertical shift. Let's go ahead and do example 3. Yeah, I think it deals with that. So for example number 3, on the same set of axes, sketch the following graphs. On the same set of axes, sketch the following graphs. So before we start sketching, I want you to see something or to note something here. You see, for the first function, which is y is equal to x squared, which is the mother function or the mother graph, you know, there is no plus something here, there is no plus q, so q is just 0 there. And then for the b function, what has happened, they've added 1 now, so y is equal to x squared plus 1, so the value of q is 1. And then for c we have y is equal to x squared plus 2, so the value of q is 2. So we said by changing the value of q, you are shifting the function up or down. So let's see how this goes about. Let's see how this shifts, okay, by sketching these functions. Okay, first thing first, let's just do the tables to make our lives easier. So we're gonna have the x values. Let's go ahead, let's go with -2, -1, 0, 1 and 2 once again. And then for a function a, okay, the y values are gonna be -2 squared is 4, -1 squared is 1, 0, 1, 4, 1, 0, 1, 4. And then for function number, I'll just keep it a bit tight here, since just to save the space. For function number b, the y values for the function number b, you just substitute the x values to get the corresponding y values. Hopefully you are aware of that. So for b, you're gonna have -2 squared, which is 4 plus 1, which is gonna be 5. And then gonna have -1 squared, which is 1 plus 1 is 2. 0 squared is 0 plus 1 is 1. And then gonna have 2, 5. And then we have number c, the corresponding y values of c are -2 squared is 4 plus 2 is 6. And then we're gonna have -1 squared is 1 plus 2 is 3. And then 0 squared is 0 plus 2 is 0. Sorry, is 2. And then this is 3 and 6. And then for d, corresponding y values for d, we're gonna have -2 squared, which is 4 minus 3. 4 minus 3, that is gonna be 4 minus 3 is 1. And then we're gonna have -1 squared, which is 1 minus 3 is -2. And then we have 0 squared minus 3 is gonna be -3 minus 2 and 1, -2 and 1. Okay, so that is basically the, what is this, the corresponding values for each function. Then it makes our lives easier to plot. Let me see if I can just put this in a table. I wanna see, it's gonna be a really tight table again. See how it comes out. That is our table. Yes, now let's sketch our functions and see how adding the 1, 2 and 3 changes our function. Remember, we said changing the value of q, which is what we are doing here. By changing the value of q, what happens to the function? It shifts up and down. So we are also expecting to see the same thing here. That's calibrate our axis. This is y-axis, and then this is x-axis. We're gonna have 1, 2, 3, 4. Okay. 1, 2. Yeah. 2, 3, 4. Okay, so we're gonna have 1, 2, 3, 4. 1, 2, 3, 4. We have -1, -2, -3, -4, -1, -2, -3, -4. Okay, let's start by plotting the function of a, which is y is equal to x squared, just the matter function. So we have -2 and 4. It will be around there. -2 and 4. We have -1 and 1. -1 and 1. And then we have 1 and 1. It would be there. Then we have 2 and 4, of which will be there, 2 and 4. Okay, I forgot to put 0 and 0. And then once you are here, you already know that we have to join our point to form that curve. Okay, and then from there, so that is the original function, or the matter function of y is equal to x squared. For function number b, what have they done? They added 1. Now q is 1. For function number a, q was 0. Okay, let's plot the points. So for -2, -2 and 5. So -2 goes with 5. Oh, forgot to do something here. This would be 5 and 6. Yeah, 5 and 6. Okay, so -2 goes with 5. So the first point would be there. And then -1 goes with 2. -1 goes with 2. And 0 goes with 1. 0 goes with 1. 1 goes with 2. It would be there. And then 2 goes with 5, somewhere here. Okay, and then what do we do next? We join our function. We formulate the curve, and look what happened here. Our function has shifted up by 1 unit. The function has shifted up by 1 unit, So as you can see that here, for the purple function at 0, where x was 0, also y was 0, so we had a point there. But for the b function, since it has been shifted by 1 unit, where x is 0, what is y? Y is 1. So you see that the function has shifted upwards by 1 unit. Let's go to number C. Let's plot function number C, where x is equal to -2, y is 6, where x is equal to -1, y is 3, and then we have 0 and 2, we have 3, we have 6, and then from there we join the curve. You see, the more we increase the value of q, the more we add bigger and bigger number. Our function just keeps on moving upwards. It just keeps on moving higher and higher. Okay, and then what happens now when we subtract a value of q? a value of q. As you might have expected, when you subtract a value of q, the function is supposed to move or to shift downwards. Let's see when we plot this function. When we plot this function, we have negative 2 and 1. Negative 2 maps goes with 1, negative 2 goes with 1, and then we have negative 1 and negative 2. So negative 1 goes with negative 2. Can I have a point there? 0 goes with negative 3. 1 goes with negative 2. Then 2 goes with 1 here. Then we join our points. As you can see what happens. So the function has shifted down by 3 units. Come here and look. Let's check this out. This is the original function. I should have actually done it in black, since this y is equal to x squared. When x was 0 here, y was also 0. And here, for the trin function, when x is 0, the trin function, which is y is equal to x squared minus 3. What is y? Y is negative 3. When x is equal to 0, y is negative 3. So the function has shifted downward by 3 units. So that is what's happening there. Let me just say, put some annotation down 3 units down. So when we are subtracting, the function will shift down. So for p, we added 1. For function number p, we added 1. So what was happening? The function shifted 1 unit upwards. For p. So I'll just say 1 unit upwards from the original function. So it shifted upwards. I can even just put, what is this thing? And then for function number c, y is equal to x squared plus 2. They added 2 units to the mother function, so the function shifted 2 units upwards. It's 2 units upwards. That is 2 units upwards. That is what is happening. The function was shifted upwards. So I hope this helped in driving the point home that changing the value of q there in the general equation determines what the shift of the graph up or downwards. It determines the shift of the graph up or downwards. And it is also the y-intercept, where x is equal to 0. It's where the what you call this thing, our function cuts the y-axis. It's the y-intercept, as we are highlighting those points. Okay, next let's go into example number 4. So now we're dealing with combined, yes, ding. Okay, so for example number 4, we're given those 3 functions, which is y is equal to 1 over x squared and y is equal to 3 over 2x squared, y is equal to negative 4x squared, and then we are asked to sketch these graphs. And then for question number B, which graph has the arms closest to the y-axis? Okay, are the parabolas concave, up or down? Actually, question number B and C, I think you can answer them without even sketching the graph, because we understand that as the value of A increases, the graph or the arms of the graph gets closer and closer to the y-axis. So we simply have to check the graph with the biggest value of A, and without considering the sign, we just go ahead and look. We have 1 over 4 and 3 over 2, which is like 1.2. 1.5, and then we have 4. Obviously that function has the arms which are closest to the y-axis. Okay, and then the parabolas, concave, up or down, what did I say we use? We use the sign of a. So only one sign or only one function has the negative sign of -4, which means that is the only function that is concave down. Okay, but without wasting any time, let's go ahead and sketch these functions. I will quickly just do the tables. Let me in fact write this one in red. So we have function number 1. Just gonna do it like this: 1/4 x squared. So we're dealing with function number 1. Let's choose values for x. Let's take -2, -1, 0, 1, and 2. Okay, we'll use these values to sketch the function, and then the y values is going to be corresponding y values negative. So we have 1/4. We punch in our calculator. -2 squared is going to be 1, and then -1 is going to be 1/4, and 0, 1/4, and 1. So that's the first function. The second one, which is y is equal to 3/2. Well, they didn't actually say we have to sketch these ones on the same set of axes. Let me see. On the same sets of axes, so we can basically separate them. Hopefully that would be of some benefit. For the second function is y is equal to, but either way I'll just use different colors. Y is equal to 3/2 x squared, and then x, let's choose -2, -1, 0, 1, 2. The y values are gonna be 3/2 multiplied by -2 squared. This is 6, and then -1 will be 3/2, 0, and 3/2, and 6. Okay. Yeah. Okay, let's find the values for the last function, which is y is equal to -4 x squared. We haven't done that one. Okay, I'm not sure. So for the function of y is equal to -4 x squared, x values, we're gonna go with -2, -1, 0, 1, and 2. Y values is I think it's gonna be 16 here. -4 times 4 times 2 squared, -2 squared. Yeah, it's -16, -16, and then I have -4, 0, -4, -16. So those are the values. What do we down here? Those are the values. Now let's sketch these functions. Let's sketch these functions. Okay, and then we'll just copy. It's 3 different functions. Yeah. I'm trying to move it a bit down, trying to provide some space for the other functions. Yeah, hopefully that will work in our favor. Okay, let's go ahead and plot these functions. Well, first thing first, I need to calibrate our axes. These are the y-axis and these are the x-axis. We're gonna have 1, 2, 2 and 3. 1, 2 and 3. 1, 2, 1, 2. So it's 1, 2 and 3, negative 1, negative 2, negative 3, negative 1, negative 2, 1, 2. Okay, let's plot the points. Negative 2 goes with 1, so we're gonna have a point here, and then negative 1 goes with a quarter, so just below the half, and then 0 and 0, 1 and a quarter just below the half, and then 2 and 1, 2 goes with 1, and then from there we simply have to join our function. So by this you can already start answering some of the questions, but let's plot all of them. Oh, I also need to calibrate this one. We're gonna have 1, 2 and 3. Gonna have 2, 4 and 6. 2. Gonna have 2, 4 and 6. Gonna have 1, 2 and 3. So it's 1, 2, 3, 1, 2, 3. Oh, sorry, this one I'll use the intervals of 2, 2, 4, 6. Actually, I should have used the intervals of 3, but it's fine. Here we have negative 1, negative 2, negative 3. Here we have 2, 4 and 6 there. Okay, let's plot the points. Negative 2 goes with what? Goes with 6. Negative 2 goes with 6, and then negative 1 goes with 3 over 2. 3 over 2, when you punch in your calculator, is actually 1 over 2, 1.5. So it's 1.5. So just about here, almost 2. And then we have 0 and 0. We have 1 and 3 over 2, and then we have 2 and 6. And then we plot our curve. That one is a bit off. Yeah. And then next we plot our curve. And that's the second parabola. Let's plot the third one. That one needs to be a bit longer because now it goes to 16. It goes to 16. Yeah, just try to move it there. Okay, and then for the final function, let's calibrate. It's 1, 2, 4, 8, 12, 4, 8, 12, 16, 1, 2, 3. So it's 1, 2, 3, 1, 2, 3, and here we're gonna have 4, 8, 12, minus 4, minus 8, minus 12, minus 16, minus 16. So when you are calibrating your x-axis, you can use any intervals. Just make sure that they are the same. If you are using maybe the intervals of 2, you can say 2, 4, 6, 8. 10 and so forth, so that your graph can come out nicely and not skewed. Okay, for the last one, let's use green. So let's plot. -2 goes with -16. -2 goes with -16, so we're gonna have a pointer there. And -1 goes with 4, so we have a point here, and 0 and 0, and then we have 1 and -4, and 2 and 16. That is our function. We join our function there and there, and it's facing down. Okay, so as I've said, that we could actually answer these 2 last questions just by looking at let me add the page, journals, custom, create. So for B, which graph has arms closest to y-axis? So it's always the one with the biggest value or the largest value of a, without considering the sign. And out of the 3 functions, we can see that -4 or 4 is actually the biggest, so it's the last graph. So for B, this is B, we'll just say the graph of y is equal to -4x squared has arms closest to y-axis. That's the graph. And then are the parabolas concave up or down? We can see that the first one is up, this is concave up, second one is up, and this one is down. But also just by looking at the what you call this thing, at the signs, because the graph is gonna be concave down if the sign is negative, the sign of A. So only the last graph is essentially concave down, because of that negative sign there that we had there. Okay, so for C, just for completeness sake, you can say, what is the function? It's y is equal to 1 over 4 x squared, and we say concave, it's facing upward, so we say it's concave up. The second one is what? Y is equal to 3 over 2 x squared. Y is equal to 3 over 2 x squared. The sign of the value of A is positive, so it's concave up again. Concave up. You've also seen from the sketches that we have made. And then lastly, we have y is equal to negative 4x squared, and you can see it's concave down. It has a negative value of 4, so it should be concave down. It's a negative value of A. Remember that -4 stands for the A, which is what we introduced here. That if the value of A is less than 0, is negative, the graph will be concave down, as you can see the set face there. Okay, and then next we have example number 5. We are given those 2 graphs, and then we are asked to sketch the graph on the same set of axes. We are asked to sketch the graph on the same set of axes. Okay, and then for B, we asked to determine the coordinates of the intercept. To determine the coordinates of the intercept. Okay. All for these two graphs. Okay, and to remember that for y-intercept, x is equal to 0. For x-intercept, y is equal to 0. Okay, so let's go ahead and sketch these two graphs on the same set of axes. Okay, so makes our lives easier. Let's start with the table. I think it will make our lives easier. X values, let's choose -2, -1, 0, 1, 2. Okay, and then the first graph of B, sorry, say A, let me use different thingy color. These are the y values for the first graph. So it's -4 times -2 squared plus 4. This is equal to -12, and then -1 is 0. Okay, y is 0 there, and then 0 is 4. And then lastly, that we're just gonna have 1 and 2, 0 and -12. That is for the first function, this one. And then let's find the corresponding y values for the second function. Y is equal to -x squared minus 2. Y is equal to x squared minus 2. Okay, so it's negative 2x squared minus 2. Okay, so the y values for the second function, the corresponding y values is -6, -6, and -1 is -3, 0, 0 is -2, 2, and 1 is -3 is -6. Before we also get to sketching these two graphs, as you can see here, do we have, oh, we don't know. As you can see here, that we have the value of a, which is -4. A negative value of a means that this function will be facing down. Same thing happens here. The value of a is -1. So both of these functions are just going to be facing downwards. Okay, but without wasting any more time, let's go ahead and sketch these functions. Start by drawing our set of axes. Okay, set of axes, there we have it. Okay, and this one is x and y. Okay, now we're gonna have, let me see, I'm gonna calibrate this one. If I say 2, 4, 6, 8, 10, 12, barely making it. 2, 4, 6, 8, 10. Let me extend this one. 12. So I have 1. Let me open this one a bit. 1, 2, 3. 1, 2, 3. So I'm gonna have -1, -2, -3, -2, -4, -6, -8, -10, -12. 1, 2, 3, it's 2, 4, 6, 8, 10, 12. Okay, let's plot the first one. Where x is negative 2, y is negative 12. So negative 2, y is negative 12. So the first point is there. Negative 1 is 0, y is 0. So we have a point there. Where x is 0, y is 4. We have a point there. 1 is 0, 1 and 0, sorry. And then 2 and negative 12. 2 and negative 12. 2 and negative 12. And then we join our points. We join our points. Yes, that is how our function is gonna look. Okay, and then next, let's do the trin function. And this is a curve. This is a curve. Okay, for the trin function, the points is negative 2 and negative 6. Negative 2 and negative 6 here. It's the first point. Negative 2 and negative 6. Negative 1 and negative 3. So negative 1 in between this. Negative 3. And 0 and negative 2. 0 and negative 2 here. 1 and negative 3. And then 2 and negative 6 here. And then we draw our function. Understand something? Yes, that is our function there. So it's also facing down because the value of a was negative. So this function here, the trin one, is equal to negative x squared minus 2. And then the other one is negative 4 y is equal to negative 4x squared plus 4. And then we also determine the coordinates of the intercept. I will just put them here on the graph. So for the purple function, the first one, we have y-intercept there at 0 and 1 and 0 and 4. So the y-intercept here is what? Is 0 and 4 coordinates. That is y-intercept. And then we have the x-intercept at negative 1 and 0 and 1 and 0. Those are your x-intercept. Then for the trin function, it doesn't intercept the x-axis, but only the y-axis. And where? At 0 and negative 2. 0, where x is 0 and y is negative 2. That is the y-intercept of the trin function. So we have determined the coordinates of the intercept for both functions. And there you have it, folks, and this marks the end of our lesson on parabolic functions. For today, we're gonna be moving on to exponential function. Please stay tuned, and then once we have done the introduction, we'll then look into doing past exam papers. Until we meet again, I wish you good luck and good studying.